Welcome to Chapter 7, Ionic Equilibria, Solubility Equilibria. First, we define what is solubility, molar solubility, and solubility product, Ksp. Solubility is the maximum amount of solute, it can be in gram, mole, or kilogram, that can be dissolved in a given quantity of solvent to form a saturated solution at a given temperature. The solubility of a salt can be expressed in solubility unit gram per liter, means that grams of solute dissolve in 1 liter of a saturated solution. Second, molar solubility. The unit is mole per liter. Mole of solute dissolved in 1 liter of saturated solution. A very soluble ionic salt, for example sodium chloride, dissolves in water and completely dissociates into sodium ion and chloride ion. Some salts are only slightly soluble in water, and an equilibrium exists between the dissolved and undissolved compound. Okay, so let's look at this. If it's a slightly soluble salt, okay, it is undissolved solid salt, and these are the dissolved ions, but it dissolves very little only. Okay, let's look at what does it mean. Silver sulfide is almost insoluble in water. When solid silver sulfide is shaken with water, a tiny portion of the silver ions and sulfide ions would break away from the surface of the solid and go into solution. Over time, some of these will return from the solution to stick onto the solid again. Thus, equilibrium is reached when the rate at which some ions are breaking away is equal to the rate at which others are returning. The position of this equilibrium lies very far to the left, means that the great majority of silver sulfide is present as solid. Solubility product constant, Ksp, or sometimes we just know it as solubility product. So solubility product Ksp is defined as the product of ion concentrations in saturated solution, each raised to the power of its stoichiometric in equilibrium equation. Okay, same thing again, it is product over reactant. However, the reactant is insoluble solid. Okay, so we do not put into the expression of solubility product. Okay, for example, we have barium sulfate. So barium sulfate is ignored because it is a pure solid. Thus, its concentration is constant. Ksp provides a quantity measure of solubility of slightly soluble salts. The magnitude of Ksp is measured how much of the solid dissolved to form a saturated solution. The more soluble a substance is, the higher the Ksp value it has. Okay, let's look at this. Okay, we have two solid here. We have magnesium carbonate and lead sulfate. Okay, let's look at the Ksp. Okay, both of them are -8, and then we have one is 3.5, another one is 1.6. So if the Ksp value is higher, the solubility is higher. Thus, magnesium carbonate is more soluble than lead sulfate. Okay, note, soluble ionic products is 100% soluble and dissociate in water. Such as sodium chloride, it will have no Ksp value. Thus, our arrow must be reversible. Okay, that's all for Ksp.